Hey guys, this is Jeremy, and let's go ahead and jump right in. Okay, so I am working on a Mac, so the first thing I need to do is open up Terminal. Okay, and as mentioned, we need to SSH into our server with if you are working on a Mac, the command is SSH your pawprint at your server name, which in our case it's tc.arnet.missouri.edu. This will not change, shouldn't change it all through the semester. If you are working on a Windows machine, please refer to the instructions that are above, as you will be using PuTTY as a SSH client to connect from a Windows machine. Okay, follow the prompted instructions, type my password, and if you have a correct username, correct password, you're good to go, you're logged in. You should see this screen right here. So this has taken us to the desktop on our specific profile, right? So for my pawprint, if I use what's called an ls command, ls is to display the contents of the directory that you're in. And again, your current directory or folder that you can think of that we're on is just, again, our desktop. It's our landing directory as soon as we log in. So as I hit ls, notice how I have worked on here before. So there are there's stuff that is here, right? So the equivalency of this on a Mac at least, and I guess it's the exact same on a Windows, is when I'm on my desktop in File Explorer, it automatically displays the contents that are on my desktop. So again, we use the ls command to simplistically display what is in our current directory. That is what ls does for us. So the next thing, you guys, again, after your ls, you shouldn't see anything because as of right now, you don't have anything on your in your home directory. So you actually might see this data, this local scratch and scratch, but totally ignore it. Not a big deal. Don't mess with that. Anyway, moving forward, so the next thing I want to go over is how do you create a directory on Linux? It's the command mkdir, which stands for make directory. So I'm going to go ahead and make a CS1050 directory. So it's the command space and then the name of the directory you would like to create. Okay, so now if I do an ls command one more time, we notice that this CS1050 directory has now been created. So how do we enter that directory? Well, it's as simple as cd, which stands for change directory, and then the directory name. So I'm going to start typing CS, and I'm going to stop there just to show you guys a little trick. So essentially, if there's nothing else in my directory that begins with CS, which I don't at a quick glance see that, if I hit tab, it performs an autocomplete. Because nothing else starts with CS, it knows that the remaining characters that are going to go on here must be 1050. So just a cool little trick to speed some things up. So after we cd into CS1050, notice how on all of these right here, they start with this little squiggle, right? So essentially, again, just refer to that in your mind for right now. Just think of that as your desktop. So now we're no longer on our desktop. Now we've changed into another location that's on our desktop, which this case it's telling us we're currently in the CS1050 directory. So real quick, I'm going to do an ls command again to list the contents of my current directory. And this is probably what you guys saw when you did this at first. Nothing popped up. So, which that's normal. I just created the directory and there's nothing in there. So we're good to go. Okay, so the next thing we want to go over is how do we program? We're going to be working with a text editor that's called Vim. Okay, so let's go ahead and demonstrate this. So the text editor Vim is essentially its own command that takes the name of the file you wish to open in the Vim text editor. So in our case right here, I'm just going to call our file test.c. So I hit enter, and notice right here at the bottom, we are working on test.c. It is a new file, so if we do not save this file, it will not actually exist in our directory. Okay, so let's go ahead and do that real quick. Immediately, if you wish to save the file or quit the file, there are two commands within here. You have to hit its shift to get a colon up, right? And then if you hit Q exclamation point, that's quit without saving, or force quit. And notice when I ls, there is still nothing in our directory. Another cool thing that we can utilize here on the command line is to go back to previous commands. I can use the up arrow. So notice how 2 commands ago it was vim test.c, but I can also hit the down arrow to go back one as well. So we're going to open this again, and instead of immediately quitting out of this file, I'm going to do colon WQ, which is write quit. And what writing means essentially is saving. So as long as we save this file, let's do another ls, bam. So now test.c is now present in our CS1050 directory. Now real quick, if you use this cd command with nothing after it, okay, so just cd and hit enter, that takes you back to your home directory, or your quote-unquote desktop. So if I do another ls, you can see it's populated with everything that we had from earlier, because we're at the same location, and there's our little squiggles back. So I'm just going to go ahead and change back into CS1050, little tab there for autocomplete. I'm going to ls again, and our test.c file is still present. So I guess from there, let's go ahead and now we can go over I guess there's a cp command. So cp stands for copy. So if I want to copy a file into another file, right? So just work with me here. So test.c, I want to copy the contents, which we know as of right now, there's nothing in there. It's totally empty. It goes cp, then the source of what you wish to copy, and then the next argument is the destination. So I'm going to call this test2.c. So if I ls again, we now have 2 files here. And of course test.c was empty to begin with, so if I open up test2.c in our Vim text editor, we notice there's nothing there as well. Okay, so let's go ahead and let's Vim back into test. Okay, so now just to demonstrate that the copy command truly does work if there is anything in content in the file, let's go ahead and we hit I for insert mode, and that allows me to start typing away. So I'm just going to type, hello, germ, what's up? Okay, and then I hit escape to exit out of insert mode. I hit colon WQ again to right quit so I save it. And now I want to try that copy command by using my arrows to get back to an old command I used. I want to use it again. Okay, but now if I use vim test2.c, this should have the same content that my other file has. And it does indeed. We're in test2.c. And here's the text from my other file. So now I'm just going to quit without saving. There's nothing we need to save. And let's go ahead and we'll go over one more command, and then we're going to go ahead and start with our Hello World program, and then we're done for the first week. As long as you guys understand these commands and follow along with this first program, you're good to go. So the next one, or the final one we're going to go over is the move command. So what I want to do is I'm going to move my test.c. I'm going to go ahead and move that back onto my desktop. So it's no longer in the CS1050 folder. I'm going to put it back on my home directory. So I'm going to move that to, if you put // what this means right here, there's going to be a lot of little things we go over all semester, so don't really stress about memorizing all of it. I'll have little cheat sheets created for you guys that you can always refer back to. But move, and then this is what I want to move, is test.c, and I want to move it back one directory, which we know, as of right now, it's our home directory, has our CS1050 directory on it. So we're going to move it back to our home. Okay, so if I ls real quick, notice how test.c got moved. It's no longer here. If I change back to my home, notice there it is. There's test.c, which was normally not there originally. So let's go ahead and go back to CS1050. I guess there is one more command we'll go over. I'm going to say rm, which stands for remove, and test2.c. Okay, so again, there are a lot of little commands, so I need to go back and update the original sheet that I had you guys that had those original 6 or 7 commands on there because I need to add some of these. Anyway, clear makes things a lot prettier. It kind of erases everything on our screen so we don't get lost in the clutter. So it's ls again, and we're currently empty. So let's go ahead and vim, and we're going to call this, we'll just call it test.c again. And then we're going to go I for insert mode, and just go ahead and follow along. I'll do a little explaining once this is totally written. I might cut this part out of the video, actually. Okay, so I'm going to go ahead and I'll put the file contents up on GitHub with the rest of the stuff, just so you guys can copy and paste, type it in, whatever. Get the information that's on test.c. Actually, just pause your video and get this in at some point. Now, I guess we'll go over it right now. So, real quick, with C programming for this first week, you guys might have already gone over some of this in lecture, but every single C program needs what is called a main function. So every single time that we open up a file in this class, the first thing you're going to do is create this main function, okay? It will begin with what's called, and this is stuff, don't worry about it, we're going to go over this a lot later on this semester when we go over functions, but long story short is this main is returning an integer. This is the return value, is what comes before the function. This is the name of the function, main. And this right here, this is the parameters that the function takes in, which void in the C programming language essentially just means nothing. To run this program, we're going to give it no information. It doesn't need anything. So at the very top here, this little # include stdio.h, what that's doing, it's actually the standard input-output library. Now what that means is it gives us access to functions that essentially other programmers have written, and all we have to do is call them. So, and that's what exactly we've done here, is we have this printf function, and the way that it shows right here is it just accepts a string as an argument, and you'll notice here in a second that when we run this program, it actually outputs this so the user can read it. That's what we'll be using printf a lot this semester. So, and at the very end, return 0, because we told our program that here it's going to return an integer. So down here at the bottom, we go ahead and we just return some integer, being 0 in this case. It really doesn't matter. You could change this to 109, 27, 104. It doesn't matter, at least at this point right now. There's way down the road that might matter, but in this class it will not. So, again, we're going to go ahead and save that, and now, as mentioned on the GitHub document, we have GCC, which GCC is our compiler. GCC takes a C file as its input, and it outputs an executable file for us. Okay? So that's good that we didn't have any errors. If there was any errors in my code, then it would have displayed right there and it would not have compiled. So if I ls again, notice you now have this green a.out file. It might not be green depending on the system you're on, whatever. For Windows users, I'm not sure. So now, the way to execute an executable file on a Linux system is /. // means essentially, hey, run this. So then I have a I want to run a.out. And I hit enter there, and now what popped up on my screen is hello world. Okay, a little choppy, but I hope that does clear up a lot of things that we're going to go over in lab. These videos essentially are not going to be your only source of information, but I'm hoping that when students come to lab, if they're a little confused, they forgot a command, versus me getting 100 emails about some questions that can be answered, multiple times. Let's just put a video out every week and hopefully answer majority of questions. But again, if your question is not answered in this video or was not answered in lab, please feel free to reach out. Thanks, guys.